Hello everyone, today in this video we are going to solve some problems on combination of resistors. As you can see in this diagram, there are many resistors connected in a circuit and we cannot tell whether it's parallel or series, so it is a mixed combination. So today we are going to solve this kind of problem. So before we solve the problem, we should know what is equivalent circuit or equivalent resistance. Suppose you have a circuit with many resistors, and if you replace this many resistors with one resistor and current and potential difference do not change, that time these two circuit will be called equivalent circuit, and the single resistance that you have changed will be called equivalent resistance. So you can read the definition for equivalent resistance. So now let's talk about the series. As we already know, in series combination all the resistors are connected along one path. So in this diagram you can see these two resistors are connected across one path, and this one is also, as you can see, there is a bend, but still it is in one path only, there is no two paths for current. Okay, this is also. Now if you see the third one, so it has two bends but still it is having only one path for current, so this is also a series combination. And this side also, it's a C shape resistors, but still it is having only single path, so this is also a series. But if you see out here, so these two, in between there is a branch, so there is two path, so this is not the series. So out here also there is a branch, so it is also not a series combination. So in a circuit you have to look for a single path, and if there is a single path, you can say it's a series, otherwise it's not a series. And similarly for parallel, two resistors or two or more resistors has to be connected across same 2 points. So out here you can see they are connected across this point and this point, so it is a parallel. Out here also they are connected across same 2 points, it's also parallel. Out here also this side they are connected to this point, and this side they are connected to this point, so same 2 points, so this is also a parallel. Out here also this side all the resistors are connected to this point, and if you see this point also, this first resistor is also connected to this point, and the third is also connected to this point, so this is also a parallel. Now this one, so if you see this two, it may look parallel, but see out here this side they are connected across same 2 point, but this side this is connected and this one is not connected to this one, so it is not parallel. And this is also not parallel because this side they are connected to one point, but another side they are not connected, so this is also not parallel, and this is also not parallel. So for simple parallel you have to see whether they are connected across same 2 point or not. So this is also not the parallel, the last one. So while solving I'll be writing R1 R2 to denote the different resistors. So when I say R1, you'll be writing this way, R1 small subscript, not this R1 R2. So whenever I say R1 R2 or R series 1, R parallel 1, so we'll be writing this way, not this way. Now let's simplify the circuit. So in order to simplify, we should know this is a simple series and this is a simple parallel. So I have one circuit out here, so I have to simplify. Now I have to look out for this thing, whether there is simple series or simple parallel. So as you can see, this first two, R1 and R2, they are in series because it's a one path. So only I'm looking at R1 and R2, I'm not looking at others. So R1 and R2, so I can make them a series. So I'll just write R series 1. So instead of R1 and R2, I'm writing R series 1, and I'm leaving all the parts as it is, so I'm not touching R3. So instead of R1 and R2, which are in series combination, I have just, instead of R1 and R2, I have replaced it by R series 1. I'm giving the name, this is the first series, so that's why R series 1. So it has to be subscript, but I could not write out here. So when you write R small s small 1, So like this. Now second thing, in this circuit, now in second circuit you can see these two rs1 and r3 is in parallel. So they are in parallel. So instead of these two resistors rs1 and r3, I can write r parallel 1. So these two is in parallel. So these two are now equivalent. So I've got the equivalent circuit for the given circuit. So this is how I solve the diagram. So again, so this is a bit complicated circuit. Now I can see r1 and r2, they are in series, and r3 and r4, r1 and r2 in series. So I'll just write rs1. So for these two resistor I'm changing with 1, that is r series 1, series number 1. So now I can see r3 and r4, they are connected across same 2 points, so they are in parallel. So I'll write rp1. So instead of these two I'll write r parallel. So other remaining circuit I'll be keeping the same way it is. So r5n cell I'm not touching it. So now rs1 and rp1 in this circuit, they are in parallel now, they are connected across same 2 point. So instead of rs1 and rp1 I can write r parallel. So but I'll give the name r parallel 2 because parallel 1 I've already written. So this is second parallel circuit I'm getting in the circuit. So other thing I'm leaving as it is. So r5n cell will come as it is. Now third part I can see they are in series now, rp2 and r5, they are in along one line. So I'm writing r series for them. So r series 1 I've already used, so I'll write r series 2. And now this is only one resistor, so I've got the equivalent circuit, so I can use Ohm's law out here. So this is how I solve the diagram. So if I see the complicated circuit, I will see for simple parallel and simple series, I keep on simplifying the circuit unless I get one resistor, and that is equivalent resistance or equivalent circuit. So you can try these two questions, and now we'll solve the question if the resistance are given, numbers are given. So we already know that for series we'll just add r1, r2, r3, and for parallel we add reciprocal of the resistors. So now we are going to solve one question on combination of resistors. So see, this is the question: calculate the current flowing through the following circuit. Circuit is given, potential difference is given, so we have to find the current. So before we find the current, we have to simplify this circuit into equivalent circuit, and we'll use Ohm's law out here, then we'll find the current. So first thing I can see is two 10 ohms are in series, so I'll just replace 210 ohm by r series 1. So this is my first series, so I'm writing this. Now in this circuit I can see this two rs1 and 20 ohm is in parallel, other I don't see any combination, so only this parallel I can see. So I'll replace this by r parallel 1. So this is my first parallel, so I'm using this. So now in this circuit I can see this 5 ohm rp1 and 5 ohm, they are in series. So I'll just replace these three resistors by one resistor, and I call it r series 2 because I've already used series number 1. So I have to write r series 2. So I have got the one resistor for all the resistors. So this is my equivalent circuit where I can use the Ohm's law. So before I solve, I have to find the value of rs1, rp1 and rs2. So let's find the value of r and rs1 first. So this is my first simplified circuit. So as we all know, these two 10 ohms are in series, so rs1 is 10 plus 10. So this is the formula for series 1. So rs1 is combination of 10 and 10, so 10 plus 10 20. So I got rs1 to be 20. So out here I'll write the value. So near to rs1 I'll write 20 ohm. Now next job is to find rp1. So rp1 is nothing but the parallel combination of rs1 and 20 ohm. So out here you can see rs1 and 20 ohm are in parallel, so I can write 1 by rp1. So parallel of these two is rp1, so this is the formula for parallel. 1 by rp1 is equal to 1 by rs1 and 1 by 20. So this is the formula for parallel combination. So I'll put the value of rs1, which is 20. So 1 by rp1 is 1 by 20 plus 1 by 20, that is LCM is 20. So this is 1 plus 1 by 20, and this is 2 by 20. So this I've got 1 by rp1, so but I need to find rp1, so I'll reciprocate the thing. So rp1 by 1 is equal to 20 by 2, so I've reciprocated both the sides. So if you divide 20 by 2, you'll get rp1 is equal to 10 ohm. So I've got the value of rp1 also, so I'll write rp1 out here in the circuit, so that I've got 10 ohm. Now my final job is to find rs2. Now I can see rs2 is the series combination of 5 ohm, 10 ohm and 5 ohm. So see, uh, 5 ohm rp1 and 5 ohm are in series, so my rs2, this rs2 will be 5 plus rp1 plus 5. So if I put the value of rp1, which is 10 ohm, so I'll get 5 plus 10 plus 5, that is 20. So rs2 is 20. So now I've got rs2, which is 20. Now I'll use the Ohm's law out here. So as we all know, v is equal to, so out here I'm using the Ohm's law, v is equal to I rs2. So instead of r, I have rs2. Now I can write I rs2 is equal to v, and I is equal to v by I rs2. So I've cross multiplied the thing. So next I'll put the value. Now a potential is given 2 volt, and resistance I have found rs2 to be 20 ohm. So if I divide this, I'll get the value of current, that is 0.1 ampere. So this is my answer. So this is how we solve. First we solve the circuit, and we'll go to okay, I'm starting again. So this is how we solve the problem on combination of resistors. So first I simplify the circuit, and I'll find the equivalent circuit where I can use Ohm's law. Then I'll find the values of all the resistors which I have combined. Then finally I'll use the Ohm's law, and I'll get the current. So this is all the answer done in one page. You can pause the video and copy and go back and check how I have done. So this is, I think it's 2 pages, and you can try these questions. And out here you can see these two is series, and when you make this series, this 3 ohm and series of this will become parallel to each other. So you can try this. If you don't follow, let me know, and try this question as well.